other part of the country, etc. Right? This wind is also very large, but not to the extent of being planetary in nature. You call them as what? Regional wind. And the finest example of this regional wind, right? The finest example of this regional wind we have taken in the name of monsoon, my friend. Right? We have taken in the name of monsoon. Okay. Only thing is that we have not discussed about monsoon yet. We'll be discussing about monsoon. Yeah, maybe, right? It means almost maybe we'll just touch monsoon in today's class, or say for example the futuristic class we'll be discussing about monsoon. Okay, then right towards the end of last class, we started talking about this local winds, right? Generally they are small area winds, my friend. Okay, they are confined to a localized place. That's the reason you call them as what? Local winds. See, these local winds take a specific name, right? They take a specific name. For example, see, there are generic winds also. Say, for example, if you have a coastal area, we understand on a day-to-day basis, on a daily basis, we have the reversal of wind taking place, right? So when I talk about this reversal of wind taking place, you call them as what? Sea breeze and land breeze. And I also means when I talk about sea breeze, right, you know the fact that wind is always named from where exactly it is coming from. In that case, if I just call it as a sea breeze, right, it means this wind comes from what? Sea. Right, if I talk about right the land breeze, this wind will be coming from land. It means land to sea, you call them as what? Sea breeze, sorry, land breeze, and sea to land, you call them as what? Sea breeze. As simple as this. So you know, wind is always named from where it comes from. Okay, I'll just connect my mic so that the audio quality will be better. Right, my dear friends. Yeah. Right. Now, after understanding this sea breeze and land breeze, we talked about right a wind breeze called as mountain breeze and valley breeze. Okay. Now, what is this mountain breeze and valley breeze? Say, for example, again, the name says mountain breeze means a breeze that comes from mountain. See, why am I calling this as breeze? Very simple, right? They are very mild winds, my friend. The velocity of this wind is very, very less. Why? Because the pressure gradient force is not so strong. Am I right? So that's the reason the velocity of the wind, right, will be very, very less, right? Fine. So that wind which comes from the mountain, you call them as mountain breeze, and that wind which comes from the valley, you call them as what? Valley breeze. Okay. Normally we said, right, evening hours and night hours, what you will be experiencing is a mountain breeze. Morning time, particularly forenoon hours, what you will be experiencing is a valley breeze, my friend. You'll be experiencing what? Valley breeze. Okay. Right, my dear friends. With all these right local winds, generic local winds we have talked about, we discussed in the last class, my friend. So today, what we have to do, we have to continue this right wind, right, local wind. Right now, we are going to discuss about the specific names of local wind. Okay. And let me tell you, this names of this local wind is very, very important. Even whatever the examination you're going to write it, right, this is going to play a very important role. Okay. Right, my friends. So one by one, let me add it. Right. We'll just categorize this wind, my friend. Right. See, for example, first, when I just talk about the specific names, right, I'll talk about all those winds which is cold and dry winds. Am I right? Okay. Or I should say, we'll just go for first warm and dry winds, then we'll be going for cold and dry winds, right? Let me call it as what? Descending winds, my friend. All this descending winds. Now, what is this descending winds? I'll tell you. See, for example, name itself says what? Descending winds. Right. Now here, assume that you have a mountain, my friend. Right? You have a mountain. And this mountain is acting as an orographic barrier, right? Orographic barrier. Somewhere you can understand what exactly I'm trying to say, correct? You have a mountain, right? This mountain is acting as an orographic barrier. It means this mountain is lying almost perpendicular to the movement of this wind. Okay. Say, for example, assume that I have a wind which is flowing in this particular direction. In between, I have a mountain. Am I right? So what will happen? Right? If you have a mountain here, okay, what will happen? This wind will start rising along one slope of the mountain. Am I right? And it will start descending along the other slope of the mountain, right? As I said, assume that this is your wind. Okay, this is your wind. The wind is flowing in this particular direction, right? Mountain is almost placed perpendicular to the movement of wind. And let me tell you, my friend, only if a mountain is placed perpendicular to the movement of wind, am I right? Say, for example, right, this can actually act as that orographic barrier. If it is not placed perpendicular, it will not act as that orographic barrier, as simple as this. Right. Indian example, if you ask me, right, I would say southwest monsoon and say, for example, Western Ghats is the finest example, my friend. Right? Southwest monsoon and Western Ghats, finest example. Western Ghats act as a perfect orographic barrier for what? Southwest monsoon to rise and descend. Am I right? So assuming that this is your mountain, my friend. Okay. So what will happen? Right? This wind will start rising along the slope of this mountain. Right. Now, what happens to this wind which is rising? You know one thing, right? In atmosphere, as you increase the height, the temperature will decrease. Right? This phenomena, you call them as what? Normal lapse rate. Okay. So what happens at every attempt this wind or this air mass increases its height, ascending along the slope of the mountain. And of course, this slope using which this wind is rising, very popularly, you call them as what? Windward slope. Right? You call them as what? Windward slope. Correct. So what happens as it rises, it is going to cool down. Am I right? Now what will happen? Say for example, if since because it is almost say for example cooling down, already this water vapor as a gas will be there in this say for example air mass. So what will happen to this water vapor? It will start condensing. Am I right? Because the temperature is decreasing, condensation process will get initiated. I'm actually skipping one sentence here. Okay. Somewhere relative humidity will increase, right? Later I'll tell you that how exactly relative humidity increases. Okay. Now you put it this way, my friend. As the height increases, it goes for condensation, that it also becomes wet. Am I right? Windward slope is the one where you will be having plenty of cloud cover, my friend, right? You'll be having cloud cover. And of course, I understand this is going to be the wet slope in general. Am I right? It's going to be very wet. Okay, it's going to be very wet, my friend. Okay, so that's the reason, even whenever I just talk about this windward slope, always we say this windward slope will be, right, cold and say, for example, wet, my friend. Okay, so this windward slope, if you ask me what exactly will be the nature of this slope, right, we normally say this slope is going to be, right, cold and wet. Okay, why cold? Because temperature is decreasing. Am I right? Why wet? Because it's going to get initiated with condensation and it is going to result in what precipitation? It is going to be wet. So any windward slope in general will be cold and wet. On the other hand, right, what will happen along the leeward slope if you ask me? Okay, every attempt of this air mass descending, right, every attempt of this air mass descending, wind descending, okay, what will happen? It will become warm, because I understand if you decrease the height, temperature will increase. If you increase the height, temperature decrease, vice versa. Am I right? So it becomes what? Warm. My dear friends, exactly opposite to it, it also becomes what? Dry. So this air mass which is descending along this, right, leeward slope, right, leeward slope. Leeward slope, my friend. This air mass becomes warm and dry, my friend. Okay. So just to tell you, we are talking about this descending air mass, descending wind. All right. Now you may ask me a question. You only said that, say for example, wind. The definition of the wind itself is what? Horizontal movement of an air mass. Now you are saying ascending and descending. My dear friend, that is also horizontal. That is also moving along the surface. Any air mass which moves along the surface, you call them as what? Wind. Whether it is rising or subsiding, that you forget about it, but it is moving along the slopes of the landforms, slopes of a mountain, right? Still you call them as what? Wind. So my dear friends, when I talk about descending wind, we are going to talk about this wind of the leeward slope. Am I right? These are nothing but what? Winds of the leeward slope, my friend. Right? Winds of the leeward slope. Okay. So as you know, right, this descending wind is going to be warm and dry winds. This descending wind is going to be warm and dry wind. Okay, right. Now, plenty of warm and dry winds across the world we have. Understanding says nature of the wind will determine its effectivity. If I just talk about a wind being warm and dry and it is influencing a particular place, what's going to happen is very simple. It is going to increase the temperature of a place and it will increase its aridity. Am I right? So these winds, right, will increase the temperature. Increase the temperature. And aridity, my friend. Aridity means dryness. Aridity means dryness. Okay, it will increase the dryness. Okay, this is what I should understand. Okay, this is what I should understand. Now, what we'll do? So, the very important descending winds of the world we'll take it. Now, what you can do? You can directly come to this North American map. If you have Atlas with you, you can come to this North American map, my friend. Okay, some of the descending winds of the world, I'll just show you. Rocky Mountains over there, right? Westerlies climbing along the Rocky Mountains and descending along the slope of this mountain. Okay, plenty of winds we have. We have winds like Chinook. We have winds like Santa Ana. Am I right? Maybe I'll just show you. I'm telling you, my friend, this map, what I'll be bringing now, this map is very important. Whenever the time permits, you just go through this map. Okay. Based on the color coding, you will understand whether this map, say for example, this particular wind, right, is a warm wind or a cold wind. The words are not so great, right? It's not so legible, but I'll rewrite it. Don't worry. Okay. Right, my dear friends. So when I just talk about, right, we'll talk about these winds, my friend. Okay, I'm just talking about North America, right? In North America, right, you have these winds like Chinook and Santa Ana, my friend, right? Descending winds of Rocky Mountain. So first, I'll just talk about this, right? Chinook and Santa Ana. All right. So if you're there in North America, right, of course, I have this wind. This wind, you call them as what? Chinook. Okay. Chinook. Now comes the question, Chinook, right? Mostly you experience this in Canada, my friend, right? Chinook is experienced in Canada. Okay. Now comes the question, right? All these winds, what we are going to discuss about, they are warm and dry winds, my friend. Very important. Warm and dry winds. So whenever these winds influence a particular place, it is going to increase its temperature, number one. Number two, it is going to increase the dryness. Now comes the question, on the face of it, we think that, say for example, this wind will be unfavorable wind. But my dear friends, any wind, forget about the nature. See, for example, wind has all combinations. Wind can be cold and dry. Wind can be cold and wet. Wind can be warm and dry. Wind can be warm and wet. Am I right? All possible combinations of it. But only thing is that depending on the place of its influence, actually we can say whether this is favorable or not. Or I would say a warm wind in extremely cold region is a favorable wind, because extreme cold condition is not so suitable for human living. Am I right? If a warm wind comes there, it will increase the temperature. Okay. So always think it in this means, think in this fashion, my friend. Right? It's more like a moderate. Am I right? If you're there in extremely warmer condition, right? If you're there in warm areas, then if a cold wind comes in, that's a favorable condition, and vice versa, right? Cold area, warm wind comes in, that is favorable. But on the other hand, cold wind influencing a colder region, or warm wind influencing a warmer region, they are not, say for example, effective, right? They are not, right, I would say, right, they have their own problems, right? They are unfavorable in condition. This is one. Similarly, my friend, if you're having a drier region, a wet wind will be favorable. If you have a wetter region, dry wind will be favorable. So kindly have this in mind. Just because this wind is warm and dry, let me not say whether it is favorable or unfavorable. Area of its influence is very, very important. Okay. Right, my dear friends. In that regard, if you just ask me Chinook, my dear friend, Chinook is a very favorable wind. Right. Often this Chinook is called as a snow eater, my friend. Snow eater. Okay. Snow eater. And let me tell you, this is a favorable wind. Somewhere, if you want to write it, also you write it, means you write it, my friend. I'm not going to write it as a favorable wind. You can write it. Okay. No problem. I'll write it. It's a favorable wind, my friend. Why it is favorable? Say, for example, I'm just talking about Chinook, my friend. Chinook, Canada, descends along the leeward side of Rocky, snow-filled mountains of Rocky. As the warm winds descends, what happens? This warm wind will melt away the snow. When the snow is melted away, the grasslands get exposed, right? This is one. If at all, if it is grassland is getting exposed, I understand cattle can have its own grazing. Am I right? Say, for example, it is profitable or it is favorable for dairy industry. Even horticulture, right? This warm wind is very important for horticulture, right? Wine cultivation or vineyard cultivation, whatever they say. In all sense, this is a favorable wind, my friend. Okay. Now, on the other hand, Chinook is a favorable wind, I said, right? On the other hand, when I talk about right, another wind, similar wind, this wind is called a Santa Ana. Right, this wind is called a Santa Ana, my friend. The area of its influence is USA, right? Just south of this Chinook, somewhere you can find it, right? You can find it. Right, Santa Ana is USA, right? Now comes the question: is this wind favorable or unfavorable? If you ask me, I would say directly this wind is unfavorable. Why? Because USA, this part of USA is already there in warmer location. Again, a wind which is descending, and further it will make this place warmer. Am I right? This is unfavorable wind. Right? Unfavorable wind. Because USA is already warm. That's the idea. Okay. So you have Chinook, you have seen Chinook, you have seen Santa Ana, right? Two very important descending winds of the world. Okay. If you want to add few more descending winds, my friend. Okay. Right. You have this wind. This wind is called as Fogan. Right. In this map, it is given only as FOHN, right? Fogan, right? It is FOEHN. Slightly, marginally, the spelling may differ from source to source. You don't mind about it. Where exactly, if you ask me, my friend, Fogan, right, is a descending wind along Alps, right? Right. USA, right. Right. So this is along this Alps mountain, Alps, right, Europe. Again, if I just talk about this Alpine Cordillera, they are snow-filled mountains. All right, snow-filled mountains, right? And both Chinook and Santa Ana, if you ask me, right, they are the descending winds along which mountain? If you ask me, both are descending winds of what? Rocky Mountains. Okay, right. Right, my friends. Fogan. Snow-filled mountains, again, it's going to be an important, right, favorable wind. Okay. And finally, not so great a name, but still, just for namesake, if you want to include this name, you can include this name. Okay. This wind, you call them as what? Zonda. Zonda, right? You are there in Argentina, my friend. Zonda is Argentina. Am I right? Whether you take it as Argentina or simply you call it as what? Right. It is Andes. Along this mountain called as Andes, you are there in Argentina. Okay. Right. These are some of the descending winds of the world. All the names what I have given is equally important. Okay. Right. So after understanding this descending winds, my friend, now I am going to the second category of this wind, right? Like descending winds, the next category, right? Let me talk about some of the extremely cold winds, my friend, right? Sometimes you call them as what? Say, for example, polar outbreaks, right? Call them as what? Polar outbreaks. Right, my dear friends, we call them as what? Polar outbreaks. What is this polar outbreaks? See, sometimes what happens during winters, my friend, extreme winters, polar region becomes so cold. Just because it becomes so cold, right? It becomes one region of, say, for example, extreme high pressure, my friend. So, as the case, what happens? This wind, high pressure, extreme high pressure, right? So, the surplus air mass will start descending towards the lower latitudinal location, right? Peak winters, this is very, very common, right? We call them as what? Polar outbreaks. They are extremely cold and dry winds, my friend. Extremely cold and dry winds. They're extremely cold and, of course, extremely dry winds. See, whenever I use this word called as extremely cold and right dry winds, no way it is going to say, for example, be favorable in nature. Okay, it's not going to be favorable in nature. Extremely cold and dry winds. Right now, seasonally, will it happen throughout the year? If you ask me, no. Right? They are common during winters. They are common during winters. See, whenever I say common during winters, it is right. Say, for example, it is with respect to their own hemisphere. Am I right? Say, for example, if you're there in northern hemisphere, month of January, right, extending itself into February. Am I right? So if you're there in southern hemisphere, somewhere in the month of July, right, you may have this or you may experience this. Am I right? Common during winters. Am I right? They are going to be extremely cold and dry winds, my friend. Okay. In that regard, see, they're polar winds, they're polar outbreaks. Polar outbreaks. It means they generally originate from the polar regions or very near to Arctic and Antarctic region origin. Am I right? So in that regard, my friend, say for example, see, from the Canadian polar region, right, you have a wind, extremely cold and dry winds, you call them as what? Blizzards. Similarly, you have a wind, right, say for example, Argentina, you call this wind as Pamperos. See, Pamperos is not so cold like blizzards, but blizzards is extremely cold, my friend. Sometimes it goes beyond imagination. Generally, they say when this wind crosses a particular place, whatever the water body it comes across, it will freeze it. Right. Normally they say, am I right? I mean, even if you say, for example, if you're throwing a jug of water, right, it will be falling as a ice crystals or ice cubes. So cold or so extreme it is. Right. Sometimes this can be an exaggeration, but never mind. Right. This just talks about the nature of this wind. Say, for example, you know Niagara Falls. Niagara Falls. Niagara Falls. Right. whenever this wind crosses this Niagara Falls, right? Whenever this wind crosses this Niagara Falls, right? This Niagara Falls completely freezes. Am I right? What exactly you're saying here is what? Niagara Falls, right? Completely frozen Niagara Falls. And the Niagara Falls almost, say for example, getting frozen, and the blizzards, they are very closely linked, my friend. Am I right? Why am I talking about Niagara Falls right at this moment? If you ask me, very simple, very, very simple, because right, this wind crosses Niagara Falls, correct? You know where is Niagara Falls, right? Exactly the international boundary between USA and Canada, my friend. Approximately here. Am I right? Right, approximately here. Right. Right, my dear friends. So let me talk about blizzards and blizzards. Right. Once you remember, right, say for example, you type it as blizzards, you see it, right, extreme cold condition, you're going to experience it. Am I right? Drastically, the temperature will drop somewhere around 10 to 12 degrees, my friend. Okay. So the very first name, let me take it as what? Blizzards. Right, blizzards. Right, blizzards origin is USA. And the country which is normally getting affected because of it is, sorry, excuse me, normally origin is Canada, kindly excuse me. The country which gets affected by it is what? USA. Am I right? So blizzards, right, very popularly it is called as Canadian polar outbreak. It's called as Canadian polar outbreak. Right, blizzards, Canadian polar outbreak. Right? If you want to write it, you can write it. It is from Canada to USA. Origin is Canada. Right. Say for example, the place of its effectivity is USA. Am I right? Now, similarly, my friend, you also have a similar wind that is almost, say for example, having its effectivity in right Asia, my friend. You call them as what? Buran, or you call them as what? Kara Buran. Okay, I am just taking only this name called as Buran. Okay. Say for example, the second wind, you call them as what? Buran. Buran. See, Buran is also known by different names, my friend. Right? Few books, you will find this name called as Purgas. Right? So you treat it as Purgas or Buran. Correct? So I talk about this Purgas or Buran, my friend. Right? They are almost Siberian polar outbreak, sourced from Siberia. Right? They are Siberian polar outbreak. Am I right? Asia. Okay. Now, see, everybody knows. Say, for example, USA and India is almost there in similar latitudes. Now, you may wonder, how come? Right? I'll tell you what. The northern part of India, right, and the southern part of USA are there in same latitude. Okay. Now, what happens, my friend? When I talk about Canadian polar outbreak like blizzards, very easily it enters USA. But when I talk about Purgas or Buran, it do not enter India. Everybody knows what is the answer for it, but still, right, formally, let me tell you what exactly is the reason. North America, the movement of blizzards is parallel to Rocky Mountains, so very easily it enters USA. But India, it is not the case, right? India, we have Himalayas. All right, that's the reason this Himalayas, you call them as what? Wall, right? So it means this wind will not enter what? India. Why? Himalayan wall protects us from this cold Siberian outbreak. All right. See, even then you will be having some cold wind which is originating from Himalayas itself. That's a different story. But I am just telling you, right? It means the wind which comes from the polar region will be blocked by Himalayas. Okay. Right. So two winds we have just taken it. And the third wind, if you ask me, right? This wind is called as Pampero, my friend. You call them as what? Pampero, or you call them as what? Pamperos. Pampero is Argentina. Right. Argentina, my friend. Pampero is Argentina. Okay. Right. At least three winds we have taken it. Right. See, these three winds are major winds. Okay. Along with these three winds, if you want to add a few more winds, right? I'll just tell you, right? Busters of Australia, you can add it. and Bora of, right, Europe also you can add it, right? Not so important, but still I'm just giving the right names as such. 1, 2, 3, if you can remember, that is more than enough. Bora, right? Bora of Europe, northern Europe, to be very precise, right? Northern Europe, to be very precise. And my dear friends, one more wind if you're adding it, Busters, right? Busters of Australia, my friend, right? Right, Busters of Australia. Kindly excuse me, this Busters. Okay, Busters of Australia. See, Bora and Busters, they are not so cold like the other winds what we were talking about. Okay, so all the cold winds, polar outbreak, we have taken it, right, my dear friends. And one more wind also I would like to add it. Am I right? What is this wind? Maybe separately I'll just add it under this heading, right? Right. I would add this wind called as Mistral because we will not have chance to discuss about this wind called as Mistral. So Mistral, if you ask me, right, I'm just writing it separately, Mistral, right? Mistral, the area of its effectivity is what? France, my friend, right? Mistral wind is France. But when I talk about this Mistral wind, am I right? They are cold and dry winds. They are cold and dry winds. Okay. They're cold and dry winds, but only difference, they are not extremely cold and dry winds. Mistral is cold and dry winds. It is common during summers. Sorry, excuse me. It is common during winters. Right. It's common during winters. But only thing is that they are not polar outbreak. Am I right? It is not polar outbreak. So, right. Let me not couple it with polar outbreak, but one thing let me understand. This is also a wind which is prominent during winter. They are cold and dry, but not polar outbreak. That also within bracket and write, but not polar outbreak. Okay. This wind is very, very important. Okay. By name, it is very, very important. Very common name, right? France. Okay. This wind is called as Mistral. Okay. So all these categories of wind we have taken it, right? What are the categories of wind we have taken it? Descending winds we have taken it, right? After talking about descending winds, we talked about, right, the cold polar outbreaks, right? The cold, extremely cold and dry winds, what we call them as what? Polar outbreaks, we have taken it, right, my friends? Right. Now what we'll do? The third category, we'll talk about some of the dusty winds of the world, my friend. Dust winds of the world or dusty winds. You call them as dusty winds. Sometimes you call them as what? Dust devils. Dust devils. My dear friends, these winds are warm and dry winds. These winds are warm and dry winds. By the time I say they are dusty winds, comes the question, from where exactly this dust originate? Okay, where exactly this dust originate, if you ask me, right? I understand that these dust is nothing but what? The fine particles of sand, right? Sand particles, you call them as what? Dust. Okay. Whenever I say find sand particles, it means I understand this wind should emerge or should be sourced from what? Right, a desert region. Am I right? They are generally sourced from tropical deserts. Why I am writing it as a tropical desert? Because we have different types of deserts. Tropical deserts are there, subtropical deserts are there. Am I right? Say for example, the cold deserts are there, right? This tropical desert, maybe for your understanding, let me call it as what? Hot deserts. Hot deserts. See, I don't agree with this word called as hot. I don't consider that deserts are actually hot. It may record the highest temperature, that is okay. But if you ask me, will it be hot always? No. Okay, but forget about it. Let us not debate on it. Right. Later we'll just have a greater understanding in it. Right. They are sourced from tropical deserts, my friend. Okay. So they are dusty winds, as I said. Okay. And my dear friends, because this wind is sourced from a desert region, I understand this wind is going to be warm and dry winds. Again, see, this wind, just because this wind is warm and dry winds, I cannot say, for example, whether it is favorable or unfavorable. Earlier also we have taken the similar condition, right? On the face of it, you cannot say whether it is favorable or unfavorable. Okay, right, my dear friends. Now what we'll do, we will talk about some of the very important dusty winds, right, which is having its origin from Sahara as a desert, my friend. Right, Sahara as a desert, the world's largest tropical desert. Am I right? World's largest tropical desert. Some of these, winds, we'll just take it for our discussion. Okay. Right, Sahara, all these winds, they are sourced from Sahara. Okay. Right, my dear friends. In that regard, the very first wind, what I'm just taking is this wind called as Harmattan. Harmattan. Right. So about this Harmattan, all the winds, what I'm just going to discuss about, they have their origin from Sahara. Right? All this wind. But only thing is that area of its effectivity, I'll just tell you. Say, for example, when I talk about Harmattan, Harmattan is, say, for example, having its effectivity in Gulf of Guinea region, my friend. Gulf of Guinea. Right. Gulf of Guinea region. See, where is this Gulf of Guinea? Right? You have, say, for example, almost, if you're there along these countries, my friend, Ghana, Togo, Benin, Cote d'Ivory, all these countries, or let me show you, right, this Gulf of Guinea. Okay, sourced from Sahara, but when I talk about, say, for example, this region, this is what you call them as what? Harmattan. I think somewhere it is this. Am I right? Harmattan as a wind. Okay. This Gulf, you call them as what? Gulf of Guinea. So many countries you have here, right? As I said, Ghana, Togo, Benin, Cote d'Ivory, right? Right. All these countries, my friend. Okay. Now, source from Sahara, it is having its effectivity in the coastal regions of this area. Right. Now comes the question, right? If you ask me what exactly is the nature of this wind, is this wind a favorable wind or unfavorable wind? If you ask me, very surprisingly, this wind has a nickname, my friend. If you ask me, what is the nickname of this Harmattan as a wind? This Harmattan wind is often regarded as a doctor wind, right? You call them as a doctor wind. Okay. Now comes the question, okay, once you call this as a doctor wind, now comes the biggest question. Is it favorable or unfavorable? 110%, my friend. Take it, close your eyes. Right. Call it as what? Favorable wind. Okay, it's a favorable wind. Right? Doctor wind. That's the reason it is called as doctor wind. Am I right? This is a favorable wind. Right? Favorable. Right. This wind is favorable wind, my friend. Harmattan. Now comes the question, why this wind is favorable? My dear friend, this Harmattan, right, it results in, say, for example, number one, it results in it results in welcome precipitation, my friend. I'm not just saying precipitation. I'm saying it is resulting in what? Welcome precipitation. Right, welcome precipitation. What is this welcome precipitation? See, for example, simple. I am looking for rain. See, for example, temperature is so horrible, right? Hot and humid condition. Particularly in the month of September, October. What exactly you will be experiencing in Guwahati, right? Assam generally is this hot and humid climatic condition. Very hot, right? You just go out and you'll be sweating a lot. Okay. Now, Gulf of Guinea being a coastal area and being a tropical region, they experience this hot and humid climatic condition. Humidity is also very high. Am I right? And it will be hot. Okay. But by the time this wind comes in, temperature will come down. You may wonder, how come the temperature comes down, my friend? I'll show you this Harmattan wind, right? When I talk about this Harmattan wind, see, I was calling it as a dust devil, right? Somewhere you can imagine. Somewhere you can imagine, my friend, right? How exactly this wind comes in. Am I right? They're actually dust devils, right? Just imagine, my friend, how exactly this wind is, say, for example, approaching this land. Just imagine, maybe, right? Okay. A dust wind, a wall of, say, for example, dusty wind is approaching a particular place, something like that. Okay. See here. Okay. This dusty wind is approaching a particular place. Now, what will happen? How this dusty wind reduces the temperature, if you ask me? Right. More is the dust, more is the aerosol. What will happen? The sun's penetration will not happen. Right. This aerosols will scatter sunlight. Okay. That's the reason, my friends, say, for example, even after Diwali, right, Lori, right, all these festivals, if the pollution level in the atmosphere increases, temperature actually comes down. Why? Sun's rays will not penetrate further. Am I right? So that's the reason I understand one thing, it reduces temperature. Okay. Number two, what happened? All these aerosols present in this, say, for example, right, these wind, am I right? They act as hygroscopic nuclei. Okay, you forget about that. We'll come to it later. Once the temperature comes down, humidity is already higher in this region, right? If water vapor is already higher in this region, now it will go for condensation, and condensation will result in what? Precipitation. My friend, when Harmattan comes in, right, Gulf of Guinea becomes cold and wet. Earlier it is warm and humid. Now it becomes cold and wet. What is the difference between being humid and wet? I will tell you. They are related, I'm not denying it. But humidity is that water vapor that is present in atmosphere. Now it is going for condensation and it is coming as a relief in the form of what? Precipitation. Am I right? Okay. So that's the reason I said it results in welcome precipitation. It reduces the temperature of Gulf of Guinea. Gulf of Guinea experienced very warm and humid condition. One of the most irritating climate in the world, if you ask me, what is the climatic condition which irritates you most? Being warm and wet. Being warm and wet. Am I right? Okay. So that's the reason. Somewhere it results in welcome precipitation. Okay. As the case, it's a right favorable wind, my friend. Now, say for example, the second wind, my friend. This wind you call them as what? Siraku. Right. You call them as what? Siraku. Okay. This wind, right. You call them as Siraku. I'll show you this wind. The area of its effectivity is southern Europe. Effectivity is southern Europe. See, for example, what happens, right? This particular wind, right, crosses Mediterranean Sea and reaches the southern Europe, particularly countries like Italy and others. This wind reaches. So what happens? This wind is a warm and dry wind. Okay, we know that. But as and when this wind crosses this Mediterranean Sea, it collects the moisture, carries the moisture, and delivers the moisture in southern Europe. But this wind, right, delivers a precipitation, and the color of this precipitation is not so normal, right? This wind results in a precipitation which is red in color, right? That's the reason, right? This precipitation, you call them as what? Blood rain, my friend, right? You call it as what? Blood rain, right? It results in blood rain. Reddish precipitation it results in. Am I right? It results in blood rain. Okay, right. Now comes the question, okay, what about harmattan, right? Don't you think that harmattan also results in this reddish precipitation? Yes. Siracu also results in reddish precipitation. But given the chance, right, given the scenario, the red color is more with respect to Siracu, right? Why red color? Because it's all about the sand particles that carries. Am I right? Aerosols, right? So much of dust you have. This dust mixing with the water, and this, right, the water almost brings this, right, reddish color precipitation. See, India also you have similar condition which is taking place, right? You would have heard about this wind called as Lu. Lu also goes for a similar condition. Am I right? So Siracu, southern Europe, it results in a precipitation called as blood rain. Am I right? My dear friends, with it, one more wind you can add it. This wind you call them as what? Kamsil. Right? This wind you call them as what? Kamsil. Area of its effectivity is what? Egypt. Right. My dear friend, this wind is completely unfavorable because source is also a desert, destination is also a desert. See, very recently, you would have seen the Suez Canal crisis, right? I cannot call it as a crisis. This ship called as Ever Given, company Evergreen, it got stuck in Suez Canal, right? In such a way that complete, say for example, this transportation was blocked. Okay, complete transportation was blocked. Okay. Now, why exactly this ship called as Ever Given got struck? Am I right? Got struck, if you ask me. It is because it has encountered a dusty wind. This dusty wind or dust storm has made this, say for example, this ship to get struck in the sand. Am I right? If you ask me which is that wind which has almost made this Ever Given ship to almost get grounded, right? Is this wind called as Kamsin. Am I right? So Kamsin is completely unfavorable wind. Okay. Area of its effectivity, right? Or source, Sahara, effectivity, Egypt. Egypt is also, you have a desert, Egyptian desert. Okay. Right, my dear friends. All the names what I have given is some of the very important names of local winds of the world. Right. I'm telling you, this is one very popular area where the match the following type of a question comes. Okay. So kindly go through it, my friend. Okay. Right. I will take a 5 minutes break and we'll come back. Exactly 5 minutes break, we'll come back. Right, my friends, right? So some of the local winds of the world we have seen, right? I think we have seen all important names of this wind. See, for example, it's not about right memorization, right, or rote memorization, right? Which area, which wind. If you add some of the details to the wind, am I right? Say, for example, auxiliary informations, remembering this wind becomes slightly easy, correct? Right, my friends. Okay. Then just because we talked about the local winds of the world, okay, what we'll do, we'll also talk about the local winds of India, my friend. Okay, local winds of India. Again, equally important, local winds of India. See, when I just talk about all these local winds of India, they are actually confined to a particular season, my friend. Particular season. Okay. What is this particular season, if you ask me? You have seen the world seasons, right? You call them as what? Spring, summer, autumn, and winter. Cyclical order. Okay. But when I talk about Indian season, this Indian seasons are slightly different in its classification. So what I'll do, right? I'll tell you the reason why exactly I discuss about seasons of India now, because all these local winds of India, they are confined to a particular season. So slightly deviating, and if I just talk about the seasons in India, right? Seasons in India, right? Entire India, my friend. Entire India, the seasons are generally divided into, right, four, right, temporal sequence, my friend. Okay, number one, right? You call them as what? Dry winters. Dry winters, my friend. Okay. So when exactly you experience this dry winters in India, if you ask me, right? When you experience this dry winters, so generally this dry winter is experienced, say for example, from mid of December to mid of March. Okay, normal, very normally when I talk about this seasons in India, dry winter is experienced between mid December to mid March. Okay, right, and dry winter is followed by dry summers. Dry summers. You ask me when exactly this dry summer? It is mid March to mid July. Sorry, excuse me, mid June. Mid June, my friend. Dry summer is from mid March to mid June. Okay, this is a national average. Okay, national average. And the third season in India, we call them as what? Advancing monsoon as a season. Right. This advancing monsoon is otherwise called as southwestern monsoon. Okay, advancing monsoon, or you call them as what? Southwest monsoon. Right. It is from mid June to mid September, my friend. Right. It is from mid June to mid September. This is the time when you experience what? Advancing monsoon. And the last season, right? The fourth season, what you have is what? Retreating monsoon. You call them as what? Retreating monsoon. Okay. It is from mid September to mid December. Okay. See, kind of overlap we have, right? With the world season, you have kind of overlap because all these months, am I right? December, March, June, September, if you ask me, you have something which is very significant with these dates. Am I right? December 22nd, March 21st, right? June 21st, September 23rd. Am I right? December 22nd, you call them as what? Winter solstice. March 21st, you call them as what? Equinox. Correct? When I talk about June 21st, you call them as what? Summer solstice. September 23rd, again, you call them as what? Equinox. So, somewhere I understand the apparent movement of sun's vertical rays between latitudes right? They play a very important role. But only thing is that the naming almost, say for example, differs with the global scenario. Am I right? So what are the four seasons you have? Dry winters, dry summer, advancing monsoon, and retreating monsoon. Advancing monsoon is what we call them as what? Southwest monsoon, my friend. And when I talk about retreating monsoon is what you call them as what? Northeastern monsoon. Okay, right. Now everything is fine. And my dear friends, you know that whenever this March, mid of March, right? This is the time when winter will end and summer will start, right? The end of winter and beginning of summer is marked by a very famous festival, right? What you call them as what? Celebration of Holi, the means festival of colors. Holi is the one which ushers in, right? Welcomes this summer, my friend. Okay, it welcomes the summer. Okay, now comes the question. See, for example, advancing monsoon, it's going to be a wet spell in India. Retreating monsoon is again, it's going to be a wet spell in some part of India, particularly the peninsular part. To be very precise, Tamil Nadu and coastal Andhra Pradesh, it is going to be wet. But when I talk about the rest of the season, it's going to be dry. If you ask me, it's going to be really dry, answer is no. Okay. Now, my dear friends, when I just talk about this dry summer is the season, right? Dry summer season. This is the season, right, where we experience plenty of local winds in India. Plenty of local winds. And one more thing, see, when I talk about dry winter, my friend, it means what? This is cold and dry condition. Dry summer is what? Warm and dry condition. Advancing monsoon is what? Warm and wet condition. Okay. All combinations we are experiencing in India. Am I right? But when I talk about this dry summers, right? Dry summers, they exactly overlap. Am I right? They exactly overlap with the. Sorry, when I talk about dry summers, my friend, this is the season when you experience the local winds. And see, for example, this particular season of India exactly overlaps with the cropping season in India. See, all the crops that is cultivated, grown, and harvested during dry winter period, very popularly we call them as what? Say, for example, Rabi crops. Right? All that crops which is cultivated, grown, and harvested during advancing monsoon, you call them as what? Kharif crop. Dry summers, we call them as what? Zaid crops. Okay. It means what? Rabi is that crop which do not like much of a temperature. Mostly they'll be temperate crops. They don't need that much of water. That's the reason, right? I think I understand that during winters, these crops are cultivated. Finest example, wheat, mustard, finest example. On the other hand, when I talk about Kharif crop is warm crop, tropical crop. They need a lot of water. That's the reason it is cultivated during warm and wet climatic condition during the advancement of monsoon. Okay, advancement of monsoon. Okay, right. Kharif crop, my friend. Rice, any crop you name it, that is going to be jute. Right? All these are Kharif crop, my friend. Zaid. They need longer days, summer, but they don't want much of water because flowering plants, right? Flowering plants, my friend. Horticulture, right? Flower needs longer days, but water precipitation will detach the flowers from the plant, so they don't right need much of water. Okay, only what they need is bright sunlight. Am I right? With a dry condition. So generally, the zaid goes with horticulture. Rabi, sometimes you call them as what? Winter crops, right? Kharif, you call them as what? Monsoonal crops. Am I right? And my dear friends, see here. It means we have a kind of interlinking with all these topics, right? We are just going to discuss about the local winds of India. That's okay. Like directly, you could have taken the answer, but what is the reason I'm just connecting to this season is very simple. Because I understand, right? Crops, generally, when I talk about, say, for example, crops, right? Food crops, to be very precise, they are going to be there standing in the land only for 3 to 4 months. But there are crops which will be standing in a land for few years. You call these crops as plantation crops. Okay. There is no definition of a plantation crop, but if you ask me convention, any crop that stands in a land for more than 3 years, you call them as what? Plantation crop. Okay. It means these plantation crops are going to see all the seasons. It's going to see dry winters, it's going to see dry summers, it's going to see advancing monsoon, it's going to see retreating monsoon. So, in all these 4 seasons, my friend, if you ask me which exactly is that season where the plants will face difficulty in survival, if you ask me, no, anybody can say. It is dry summer. Condition is warm, right? It means transpiration, the loss of water will be more, but the availability of water will not be higher. Alright. So it means the plants will be facing a lot of difficulty in, say, for example, surviving this phase. But what I understand, local winds are prevalent during dry summer period. It means all these local winds are going to be a beneficial wind because winds brings precipitation. Am I right? They are going to be, say, for example, right, favorable for this plantation crop. That's the reason, right? Most of the local winds in India is named after the plantation what is getting benefited out of it. Am I right? Right. So with all this idea, if you ask me, okay, just kindly give me the names of these local winds. Here comes the names, my friend. And before that, I said, right, these local winds, right? They are common during dry summers. They are common during dry summers. They are common during dry summers. Okay, number one. Number two, just because they just right have their origin before advancing monsoon. Am I right? The next season is advancing monsoon. So these local winds brings precipitation before the monsoon. Correct. That's the reason the precipitation which is brought by these winds are also called as pre-monsoonal showers. They call them as what? Pre-monsoonal showers. Why? Because precipitation you are receiving before the advent of monsoon. Am I right? Generally, they favors plantation crop, my friend. Favors plantation crop in general. Right. They favors plantation crop in general. Right. And that's the reason, accordingly, when I talk about the name of this wind, most of these winds are named after the plantation crop which is getting benefited out of it. Okay. So with this idea, my friend, you are just asking me, okay, give me the names. Here comes the names, my friend. Okay. Right, my dear friends. Some of the winds which is having its influence, right? Why exactly they are taking this name? I'll tell you. Say, for example, name itself says, right? Mango showers. Why this wind is called as mango showers, if you ask me, right? The reason is very simple because it is facilitating the mango plantation, my friend. Okay. So if you ask me, okay, where all you experience this mango showers, right? It favors mango precipitation or mango, sorry, excuse me. It favors mango plantation. But what are the places in India which gets benefited out of this mango shower? See, this map is not exactly depicting what exactly is this mango shower. Generally, my friend, this is Maharashtra, Karnataka, and parts of Tamil Nadu. parts of Tamil Nadu, right? These are the states which is getting benefited out of this mango showers. Again, I'm telling you, net source. If you type it as mango showers, plenty of wiki says plenty of states are right, almost given it. Am I right? So only part you take it. Am I right? Maharashtra, Karnataka, and parts of Tamil Nadu. Then I have a shower called as tea showers. Sometimes this tea shower is also called as Bardoli Chira, right? It is called as Bardoli Chira, my friend, or you call them as what? Tea showers. Okay. What you experience? See, for example, the other name, right? You call them as what? Tea showers. See, by the time I say tea showers, am I right? The other name, it is called as Bardoli Chira. Okay. You call them as tea showers. By the time I say tea showers, you yourself can come to a conclusion that what are the different places in India which is known for tea cultivation. Of course, there are plenty. Am I right? But the prominent locations, my friend, Darjeeling Hills of West Bengal and Assam. So the tea showers bring favorable precipitation to West Bengal and Assam, my friend. Right. Assam. Assam and West Bengal. Look at Darjeeling Hills, right, of West Bengal and in general Assam, tea showers. Otherwise, tea shower, as I said, it is called as Bardoli Chira. See the spelling, C double H double E R H A, all these you forget about it. Make it simple, right? It is called as Bardoli Chira. That's it. Okay. Other name of tea showers. Favorable. Because it favors what? Tea plantation. Right, my dear friends. Then you have something called as blossom showers. Right. Either you call them as blossom showers or you call them as what? Cherry blossom, my friend. Right. You call them as what? Cherry blossom. You call them as what? Blossom showers or you call them as what? Cherry blossom. All right. Now comes the question, right? Normally, right? Which plantation it, say for example, favors? People say cherry. Where do we have cherry in India? Except the shoe polish called as cherry blossom, we don't have anything called as cherry in India. All right. My dear friends, though the name is called as cherry blossom, this is for coffee plantation. Right? It is for coffee plantation, my friend. Okay, it's for coffee plantation. Right, as simple as this way. Right, cherry blossom is for coffee plantation. Okay, right. Now, why? Because see, for example, this coffee bean, right? When it's actually going to ripen, right, it looks like cherry, bunches of cherry. That's the reason you call them as what? Cherry blossom. See, by the time I say coffee plantation, this cherry blossom, right, you can take it for default. It is there in Karnataka, right, and Kerala, my friend. Right, these are the predominant states where, right, you have this, say for example, this cherry blossom as a precipitation, right, as a precipitation having its effectivity. Okay, see the beauty, right? You call them as tea showers, you call them as cherry blossom, you call them as mango showers. So somewhere directly or indirectly you're saying that which plantation is getting benefited out of it. That's simple as this. Okay, right, my dear friends. Okay, now, right, so the very important favorable local winds we have taken it. Now, say for example, we also have unfavorable wind. See, favorable criteria, somewhere if you want to write it, what are the favorable wind? Right, somewhere you can sum it up. How about the favorable wind? Right, at least 3 wind we have in India. Right, number 1, it is mango showers. Right, number 2, it is tea showers. Number 3, it is cherry blossom, or simply you call them as what? Blossom showers. Cherry blossom, or you call them as what? Blossom showers. Blossom showers. Okay, both are same. On the other hand, my friend, if you ask me what are the unfavorable wind, am I right? Not all local winds of India are favorable, unfavorable. Talk about unfavorable wind. Unfavorable wind. Number one, mother of all wind comes this Kal Baisakhi. Kal Baisakhi. Right? Kal Baisakhi. Slightly my spelling is going to differ from the spelling what exactly you have here. Right? Kal Baisakhi. Right? In this case. Okay. Okay, otherwise I will take the same spelling, right? It is called as Kal Baisakhi. See, when I talk about this Kal Baisakhi, it is kind of a tropical cyclonic circulation. Am I right? They are known for, see, for example, when I talk about Kal, am I right? Kal means black, my friend, black, right? It means you'll be having black clouds, right? It means you'll be having this cumulonimbus clouds, right? Very dark clouds you'll be having, right? Right. And of course, it brings heavy precipitation with a violent wind. So that's the reason this wind is more like destructive in nature. Right. This Kal Baisakhi, right? You experience this Kal Baisakhi in West Bengal, my friend, coastal West Bengal, right? This Kal Baisakhi is otherwise also called as nor'wester. Other name, it is called as nor'wester. See, by the time you call them as nor'wester, I can say what exactly is nor'wester. Nor'wester means a wind which almost flows from northwestern in direction. That is what you call them as what nor'wester. Okay. So Kal Baisakhi is destructive in nature, right? And number two, my friend, right? You have a Lu, a wind called as Lu. My dear friends, this Lu as a wind, right, is sourced from Thar Desert. Right? This wind is sourced from Thar Desert. Okay. This sourced from Thar. Okay. But when I talk about the area of its effectivity, Gangetic. Okay. Lu. Effectivity, if you ask me, it is Gangetic. Okay. Sourced from Thar, but entire Gangetic plain has its effectivity from Lu. Lu is a dusty wind, my friend. Right? It's a dusty wind. Every summers, right? Very recently also you would have seen, right? Dry summer period. Till May, you will be finding this phenomenon. Entire Delhi, you will be having this dust storm which is covering, right? Say, for example, the entire visibility, reducing the entire visibility as such, right? You call them as what? Lu, right? Lu. It's nothing but a dusty wind. Am I right? Again, if you ask me where exactly the dusty wind or normally originate from, right? Any desert, sandy desert. Am I right? Thar is the sandy desert there. Am I right? Right, my dear friends. Now, the very important local winds of India. Their alternate names. What exactly is the other name? What exactly is the popular name? What is the nature? Where exactly is the area of its effectivity? Everything they have seen. Am I right? Right. Mango showers. What are the places? Right. Tea showers. What are the places? Blossom showers. What are the places? Kal Baisakhi. What is the other name of Kal Baisakhi? Where exactly it is having its influence? Right. What is Lu? Right. Dusty wind. Right. Where exactly it is sourced from Thar Desert. Right. Where exactly it is having its effectivity? Gangetic plain. Everything we have seen with this. Right. We are just completing this. Right. Local winds of India and local winds of the world. I'm telling you again. Right. Say, for example, this particular topic, what we have taken it, my friend. Right. It's very, very important. Okay. Right. Right, my dear friends. Now, after completing all these winds, right, all these local winds, right, India we have completed, world we have completed. Then what are the other surface winds we have? Right, only monsoon. Monsoon we'll see it later. Right. Then we have something called as upper air wind, my friend. This upper air wind, we call them as what? Geostrophic wind, or generally we call them as what? Jet streams. Again, a very important concept. Right, you call them as what? Jet stream. You call them as what? Upper air wind, or simply you call them as what? Jet stream. Now comes the question, okay, why exactly these winds are called as jet stream? Why exactly this wind has become geostrophic in nature, right? Please, can you scroll this slide bit up? Means you want to take these names, okay. See, once the class is over, I'll be sending this all these image files, okay. For your class, I have just saved a folder with it, okay. So all the files, what exactly I've used it, right? This annotation and other things. I'll be saving it as an image, then I'll be sending it to your Chris sir. Okay. So Chris sir will be sending it to you. Okay. So don't worry. Some of the things, if you would have missed it in the class, right? Later also you can add it. Okay. Right. But anyhow, yeah. Right, my dear friends. Now coming to this jet stream, my friend. Coming to this jet stream. What is this jet stream? See, for example, jet streams are upper air wind, my friend. Or sometimes we call them as what? Upper air geostrophic winds. Okay. Upper air geostrophic winds. See, what is this geostrophic winds, if you ask me? Okay. Very technically, we say any wind which flows parallel to the isobars, you call them as what? Geostrophic. Maybe you take it this way. A wind which encircles the earth, you can call it as what? Geostrophic wind. Jet streams actually encircles the earth, my friend. Okay, right. Jet streams generally encircles this earth. Okay, what is this jet stream, right? Why exactly we have jet stream? What exactly is the flow direction of a jet stream? Everything you understand. Okay, see, jet stream has a very big history. Okay, it has a very big history, my friend. We are not right interested in knowing the histories as such. Okay. See, we have few winds, okay, which encircles this earth, my friend. Encircles this earth, and they generally flow in this west to east fashion, my friend. And that's the reason sometimes they call them as what? Say, for example, a westerly wind, right? They don't flow at the surface level, they flow at the tropopause level. Am I right? Okay, generally, that also I'll write it. They are not surface wind, you already know, right? They are, right, wind that is flowing at tropospheric level. That right, they flow at right tropospheric level or tropopause level. Flow at tropopause level. Right, they flow at tropopause level. Okay, now comes the question. Why exactly it is called as jet stream? Right? Make it very simple. It is all because of what? Velocity. Velocity, right? These winds have very high velocity. Now comes another question. Why is that this wind is having so much of velocity? Is it because of pressure gradient force? No. It is not because of pressure gradient force. It is because of what? Right, the frictional drag, my friend. Upper air, you won't have that much of friction. That's the reason the velocity of the wind is very, very high. Okay. So sometimes, right, you can take a definition, my friend. What exactly is it? Jet stream. You can write it. The fast moving centers, of an upper air wind, the fast moving centers of an upper air wind, which has a velocity, of more than 200 kilometers per hour, which has a velocity of more than 200 kilometers per hour is called as jet stream. So why it is called as a jet stream, we have an idea. It is all because of what? Velocity classification. They are high speed wind or high velocity wind. As I said, the velocity of this wind is more than 200 kilometers per hour. That's the reason you call them as what? Jet stream. Okay, everything is fine. Right. They flow at tropospheric or tropopause level. That is also great. Okay. Now, few more things we'll add it. And maybe see, for example, what I'm just giving you, right, is an aerial image, but approximately at what latitude, right, they'll be falling. That also I'll just tell you, my friend. Okay. Normally, my friend, say for example, this is somewhere around 0 degree. Okay. This is 30 degree. This is 60 degree, something like that. Okay. Right. You forget about the names, right? Somewhere around 0 degree. This is 90 degree. Okay. Right, my friends. Some of the names is given within the cells. Am I right? You call them as what? Hadley cell. You call them as Ferrel cell. You call them as polar cell. All these cells name you forget about it. Okay. Now, where exactly? This is tropopause level, my friend. I told you, right? They flow at tropopause level. This is your tropopause level. Okay. This is your tropopause level. So these jet streams flow at tropopause level. Okay. Right, my dear friends. Now comes two very important observation. Number one, I told you these winds, right, flow at tropopause level. But what exactly is the direction of this flow? These winds flow from, right, they flow, right, in west to east direction, right? They flow in, right, west to east direction. West to east direction. Right. And that's the reason, say, for example, right. That is the reason, my friends, sometimes this wind is also called as a westerly wind. Very rare occasion, it is called as a westerly wind. Because you know, right, a wind which flows from what? West to east, you call them as what? Westerly. Am I right? My dear friends, just because it is flowing from west to east, am I right? Right, this wind is encircling the entire earth. Am I right? See, for example, this wind do not flows in perfectly east-west in direction. It also oscillates between slightly latitude and altitude. Okay. My dear friends, just because, as I said, it is moving from west to east, it encircles the entire earth. Now comes the question, okay, everything is fine, but why? Why is that it is flowing through west to east in direction? If you ask me, reason very simple. You take it as what? Right, rotation of earth, my friend. Right, it is all because of what? Rotation of earth. Right, or even if you say, okay, Coriolis force, I don't mind. I mean, simply you say it has become, eventually it has become, right, geostrophic in nature, right, or encircling the earth just because of what? Rotation of this earth. Completely it becomes geostrophic. What is geostrophic? Technically, I told you, right, any wind which goes, starts flowing parallel to this pressure gradient force, you call them as what? Geostrophic winds. Okay, right, my dear friends. I was simply saying that these winds flow from what? West to east in direction. As the case, they encircle the entire earth west to east. Okay, they encircle the entire earth. Okay, everything is fine, right? What is jet stream? Where exactly they flow? Am I right? Now, if you ask me, how many jet streams are there? Okay, how many jet streams are there? Both in northern hemisphere and southern hemisphere, you have jet stream, but in general, okay, what are the jet streams? If you ask me, generally, there are two jet streams, my friend. There are two jet streams. Right? What are they? Number one, we call them as what? Subtropical. Right? Subtropical jet. Okay, you call them as what? Subtropical jet. Number two, you call them as what? Polar jet, my friend. You call them as what? Polar jet. But what happens, this polar jet, only two jet streams are there in one hemisphere. But this polar jet, what happens during winters, my friend? Only during winters. Okay. During winters, what happens? It gets bifurcated into two other jet streams. Right? Only during winters. During peak winters. Right? This polar jet stream becomes further getting divided into two jet streams. What are they, if you ask me? Number one, you call them as what? Polar frontal jet. Right? You call them as what? Polar frontal jet. And number two, you call them as what? Polar night jet, my friend. Polar night jet. Okay. Not throughout. This jet stream gets bifurcated only during winters. All right. So what I want to tell you, few books you will be finding that there are two jet streams in one hemisphere. Few books you will be finding that there are three jet streams in one hemisphere. What is the difference? Very simple, right? One jet stream gets bifurcated into two. That's the idea. Okay, right, my friends. So subtropical jet and polar jet. Okay, what exactly happens? This is what happens, my friend. So, right, during winters, what happens, and during summers, what happens is what the idea is all about. Okay, right. Right, my dear friends. When I talk about jet stream, okay, what are the different jet streams we have, right? Right, approximately I have an idea. Now, normally we say, right, jet stream. When I talk about jet stream, see, jet stream play a very important role in inducing monsoon, I accept. Right, in general, right, the global scenario jet stream, right, may not have that much effectivity on the surface area. Why? Because jet stream is flowing at tropopause. Right. The two, when I talk about the tropopause level or height, the height of tropopause is not so constant. Polar region, the height of tropopause is only 8 kilometers. But when I talk about, say, for example, near equatorial region, the height of tropopause is somewhere around 18 kilometers, so it differs. Am I right? So assume that the jet streams at lower latitude flowing at 15 kilometer of height, very rarely it will have its influence on the surface of the earth. Right, on the surface of the earth. But there are occasions where jet streams, right, may affect the temperature or the, say for example, climate or the weather of this surface. How I'll tell you, one finest example also I'll tell you, my friend. See, for example, slightly let me deviate, my friend. Let me deviate. Okay. Just coming to this Indian geography, we have something called as western disturbance. Western disturbance. Now, what is this western disturbance, if you ask me? Western disturbance, I'm just taking with the case of India, right? Forget about the rest of the world. Western disturbance in India. What is this western disturbance in India, if you ask me? Right, this is related to jet stream. That's the reason I'm just bringing, right, this particular discussion here. Okay. But talk about this western disturbance, right? This is nothing but what? Winter precipitation in India. Winter precipitation in India. So winter precipitation in India is very popularly called as western disturbance. As simple as this. Okay, see, for example, when I talk about winters, we say it is dry winters. Correct. Now comes the question, is this winter really dry? No. This winter is not really dry. Because, see, for example, we talked something called as dry summers. Is this summers really dry? No. Few places I had local winds. Few places I have local showers. Similarly, the so-called dry winter is not really dry, right? Some places, right, you have precipitation that is resulted. Again, there is a favorable, right? This precipitation is favorable. I'll tell you that how exactly it becomes favorable. Okay. So this winter precipitation in India is called as western disturbance. Now comes the question, okay, everything is fine, right? You tell me which part of India experience this, say for example, winter precipitation. Sarcastically, I used to say that part of India which experience winter will experience winter precipitation. Correct. Now again, sometimes, see, I have just given you a clue. My dear friends, entire India do not experience two winters. Only the northwestern part of India experience true winter. And that's the reason the northwestern part of India, right? And that's the reason, my friend, this northwestern part of India, right? This is the place where normally it is known for rabi crop cultivation, my friend. If you ask me wheat cultivation, right? Wheat cultivation is not universal, right? Throughout India, you don't say cultivate wheat. Am I right? So wheat is restricted to only few places, my friend. Right. Now, what is that few places? One of the few places, if you ask me, right? So, my dear friends, when I talk about this India, I told you, right, entire India do not experience winter, number one. Okay. Similarly, I understand entire India is not going to experience, right, this winter precipitation. Okay. So if that is the case, what I can do, I told you, right, the northwestern part of India is the one which experiences two winters. Now, what you can do, you can actually divide India into four quadrants, my friend. How this division is possible, if you ask me, right, with a very important latitude and longitude. Say, for example, number one, right, you can take this very important longitude, right, this very important longitude, you call them as what? Say, for example, Tropic of Cancer. Okay. You call them as Tropic of Cancer. Okay. Assume, my friend, this is the place where exactly Tropic of Cancer passes through. Okay, 23.5 degree north. You call them as what? Tropic of Cancer. And similarly, my friend, you have one very important longitude. This very important longitude, you call them as what? Right, Central Meridian of India. Am I right? You call them as Central Meridian of India. The Central Meridian of India is nothing but what? 82.5 degree east longitude. Okay. You have latitude and longitude, my friend. Am I right? See, I have just divided India into four quadrants. Am I right? Unequal parts. Am I right? See, 1, 2, 3, and 4. Right? See, these are the latitudes and longitudes which is actually dividing India into different halves. Okay. Now, my dear friends, when I say north, see, generally, when I talk about north and south, okay, what is called as north? Whatever lies north of Tropic of Cancer, you call them as what? Northern India. South of Tropic of Cancer, you call them as what? Southern India. Am I right? Similarly, right, east of this central meridian, you call them as what? Eastern India. Am I right? Say, for example, right, west of it, you call them as what? Western India. That's the reason, my friend, why exactly it is called as northeastern. Am I right? Because it is located in north and east. That's the reason it is called as northeastern state. What is northwest? Am I right? Why exactly it is called as southern states? Right? This is the general idea. Am I right? Now, my dear friends, where exactly you experience this, say, for example, this, right? Say, for example, precipitation, if you ask me, winter precipitation, right? You experience this winter precipitation in northwestern part of India, right? This is the place where you experience winter precipitation, my friend. Winter precipitation. This is the place where you experience this winter precipitation. Okay. Now everything is fine. What is winter precipitation? Sorry, western disturbance. Winter precipitation in India. Which region in India experiences winter precipitation? It is northwestern part of India. Okay, northwestern India. Okay, northwestern India. Everything is fine. Now, my dear friends, let me tell you, this is a very favorable precipitation. Why? Extreme cold condition, what happens? This plants, crops, right? They may experience frost, right? Frost is not good for, right, agricultural practice. Frost is very bad. Frost, right, is very bad, right? Plants can die, right, during this frost. Okay. Whenever this precipitation happens, right, it will eliminate this frost, or it will check that frost is not formed. Am I right? So in a way, it is very, very important. Number one. Number two, it gives a timely precipitation. See, for example, because I know that this season is a dry season, dry winter. See, I understand. Rabi crop also needs water, but very little water. Correct? Of course, it needs water. No plant can survive without water. Am I right? It needs water, but very little water. But still, when I say very little water, how do you get this very little water? Precipitation will bring it, right? This will not bring heavy precipitation. This winter precipitation in India will be mild, so it will be very favorable. So this precipitation slightly will increase the temperature. You may be wondering, right? How come precipitation increases temperature? Simple. Water is a moderator. If it is very warm, it reduces temperature. If it is extremely cold, it increases the temperature. Water is a moderator. So slightly it increases the temperature. Number one. Number two, right? It gives you the timely precipitation for this Rabi crops, right? Number three, right? It checks frost formation. Am I right? It checks for frost formation. So all cases, this winter precipitation in India is favorable for Rabi crops. Am I right? It is favorable for Rabi crops. Even if you want to write it, you can write it as favorable for Rabi crops. Favorable for Rabi crops. Okay, right. So everything is fine. Now comes the question, right? You said western disturbance. We were actually talking about jet stream. What is the connection we have with western disturbance and jet stream, if you ask me, my friend? This western disturbance as the precipitation itself is resulted by a jet stream. What is bringing the precipitation to India? What is the carrier of this moisture that itself is resulted by jet stream, my dear friend? Right, it is facilitated, right? Precipitation is resulted by jet stream. This is jet stream induced precipitation. Correct? Right, it is jet stream induced precipitation. Jet stream resulted precipitation. See, generally, my friend, jet stream do not have its effectivity in resulting in precipitation. Why? Because the height at which this jet stream is flowing is very, very high. All right. So, tropopause level, that is so high. Only the surface wind can influence the temperature, precipitation, moisture of a particular place, not the jet stream. Okay. But what happens during winters? You know, the tropopause level will come down. Jet stream will also come down. So during winters, it may have its effectivity. Okay. Right, my friend. This is jet stream induced precipitation in India. Now comes the question, everything is fine. Even for this jet stream, you need some source, right? Where exactly this source comes from? My dear friends, this source, right, comes from Mediterranean Sea, my friend, right? That we call as what? Western disturbance. Western disturbance or Western disturbance? Western disturbances. Am I right? So this, right, say for example, Western disturbance, that precipitation, what happens in India, right? The moisture is sourced from Mediterranean region or Mediterranean Sea, right? Okay. Too much of information is given here, but that much of information is not needed, right? Only one information you have to know it, right? Where exactly this moisture is coming from, that much if you know, that is more than enough. Image is not clear. One more image, let me try it. Right, my friends. Approximately, I have also given you the source. Okay. You knowing the source is very important. The source is what? Mediterranean Sea. Okay. Then I told you, right, the carrier is from jet stream, because I understand. See, Mediterranean Sea is located towards the western side. Am I right? So the moisture from the Mediterranean Sea is collected, and say, for example, moisture is further carried towards the, say, for example, the eastern side. Am I right? And places like India, this moisture is delivered, right? And beyond it, it becomes what? Dry, my dear friends. Okay. So again, if you ask me, okay, everything is fine, jet stream, but which jet stream, right? The moisture in India or moisture to India is brought by this subtropical jet, right? It is brought by this subtropical jet. Okay, right, my friends. So jet stream induced precipitation, right, in India, right? You call them as what? Western disturbance. Which is that jet stream which is bringing this precipitation to India? That also we have seen, it is subtropical jet stream, right? With this, we are completing this jet stream, my friend. Okay, all important one. What is jet stream? What is the definition? What is the nature? Where exactly they flow? What is the direction of it? Why exactly it is taking this direction? What are the different jet streams we have, right? And how exactly it is imparting or influencing Indian climate, right? Everything we have taken it, my friend. This jet stream is over. Okay, right. Now, my dear friends, if you remember the very first class, okay, I have just given you, right, the complete flow chart of this chapter called as climatology. Okay, complete flow chart I have just given you. Okay, right, right. So here we completed this structure of atmosphere, composition of atmosphere. Then we talked about insolation. Then we talked about temperature. Then we talked about pressure. Then we talked about wind. Wind, almost all winds we have talked about. Planetary winds, local winds, jet stream. What is remaining in this wind as a chapter is called as monsoon. Okay. Similarly, when I talk about pressure, we talked about different pressure belts of the world. What is remaining, we have not taken, is the intensified pressure systems called as cyclones and anticyclones. Am I right? But anticyclones we are not interested in. We'll be discussing only about cyclone. Both the types of cyclone, tropical and temperate cyclone, we'll be discussing. Then we'll be venturing to climate, right? World climate, my friend. Right? World climatic classification. So in between, let me tell you, this monsoon and cyclone, I am just reserving at last. Okay. Before getting into it, right, we have a very small topic. I cannot call it as a small topic, but a hidden topic. Okay, hidden topic, but this topic is very, very important. Am I right? What is this topic very popularly called as? This topic you call them as what? Hydrological cycle. Okay. See, for example, whenever I talk about climate of a particular place, climate is resulted by temperature and moisture. Am I right? So now in hydrological cycle, we'll be discussing about the cycle of moisture in atmosphere. Okay, cycle of moisture in atmosphere. So the next topic what we'll be discussing is this hydrological cycle. Right. What is this hydrological cycle? Sometimes you call them as water. This is nothing but what? Water cycle in atmosphere. Right, water cycle in atmosphere, you call them as what? Hydrological cycle. Okay. Say for example, how the surface water is becoming water vapor. How this water vapor is going for condensation. How it is becoming cloud. And how this condensed material is once again, say for example, reaching the surface of the earth. Am I right? That's what you call them as what? Hydrological cycle. Correct. So somewhere I told you, right, this is nothing but what? Water cycle in atmosphere. Water cycle in atmosphere. Okay. So what happens, my friend? Say for example, assume, right, you have somewhere like the surface water, my friend. This is the place where you have the surface water. Okay. Assume that you have the surface water. Okay. So this is your surface, my friend. This is your surface. Assume this is surface. surface of the earth, and this is your surface water. Surface water. Now, say for example, it is by some mechanism, this surface water, say for example, becomes water vapor. What is water vapor? Water vapor is nothing but what? Right. Water in the form of gas. Okay. Water in the form of gas, you call them as what? Water vapor. Now, if you ask, right, how exactly, say for example, this surface water becomes water vapor, if you ask me? Of course, I understand, right? This process of water becoming water vapor, very popularly, you call them as what? Evaporation. Am I right? My dear friends, we call them as what? Evaporation. Okay, you call them as evaporation. Right. So evaporation is the mechanism by which this water becomes water vapor, my friend. Correct. Now, say for example, okay, now water has become water vapor. Right. Everything is fine. Right. Water has become water vapor. Okay. Now comes the question, right? Once it becomes right water vapor, my friend, what will happen? Right. I understand at some point of time this water vapor should go for what? This process, as I said, you call them as what? Evaporation. Right. You call them as what? Evaporation. Right? Water becoming water vapor, you call them as what? Evaporation. Now comes the question, what exactly, how exactly this water vapor, right? Water vapor in atmosphere, sometimes it has to become cloud, right? Cloud, right? How exactly it is becoming cloud, if you ask me? This process of water vapor becoming cloud, right? You call them as what? Condensation, right? We call this process as what? Condensation. Okay. Condensation. Okay. You call them as what? Condensation. Okay. Water becoming water vapor, you call them as what? Evaporation. Water vapor becoming cloud, you call them as what? Condensation. And once it forms, see, cloud is a form of condensation. Cloud is an aggregate of solids and liquids. All right. Cloud is not gas. Most of us think that cloud is water vapor. No, it is not water vapor. Water vapor is gas. It is transparent. Water vapor is transparent, my friend. You cannot see. Am I right? Cloud is liquids and solids. All right. And my dear friends, once it forms as a cloud and the condensed material once again reaches the surface of the earth. It's condensed material once again reaching the surface of the earth. Very popularly, you call them as what? Precipitation, my friend. Right? We call them as what? Precipitation. Okay. It is called as precipitation. Okay. So, my dear friends, this cycle that exists between evaporation, condensation, and precipitation. This is what we call them as what? Hydrological cycle. How the surface water is becoming water vapor. How this water vapor is once again going for condensation, how it is becoming cloud. And how this, say for example, cloud is once again becoming, right, or reaching the condensed material is once again reaching the surface of the earth. This is what you call them as what? Hydrological cycle. So kindly write it. The cycle between evaporation, condensation, and precipitation. The cycle between evaporation, condensation, and precipitation is called as hydrological cycle. It's called as hydrological cycle. So, right, my dear friends, what is hydrological cycle? We have an idea now. Okay, we have an idea. Okay, right, my dear friends. Only thing is that we have to discuss in detail what are the different ways, how right? Water becomes water vapor. How this water vapor goes for condensation, how it becomes cloud, right? What are the different types of cloud? How exactly it reaches the surface of the earth? What are the different forms and types of precipitation? This is what we are going to discuss. And again, this is a question potential area, my friend. So what we'll do, right? The first session of your class is over. We'll take a break of 15 minutes. Now the time is 11:05. We'll be back at 11:20. Right, my dear friends, I am back. Yeah. Okay. Right. So somewhere we were just talking about this hydrological cycle. Okay. What is this hydrological cycle? Right. Somewhere I told you, right? In simplicity, right? This water cycle in atmosphere, you call them as what? Hydrological cycle, right? As I said, it is just water cycle in atmosphere, my friend. Okay. How the surface water is becoming water vapor and how this water vapor is becoming cloud and how this water from the cloud is again reaching the surface of the earth. You call them as what? Hydrological cycle. My dear friends, as I said, individually, if I just talk about hydrological cycle, these, say for example, topics are very important. First, I'll talk about this water vapor in atmosphere, right? One by one, right? Each and every compartment of the cycle, we just take it for our discussion. Okay, right. So in that regard, my friend, right? First, I'll just start with this, right? The very first compartment, water vapor in atmosphere. This water vapor in atmosphere is very popularly called as atmospheric moisture or humidity. Right, you call them as what? Atmospheric moisture or humidity. Okay. See, there is a slight technical difference between both these things, right? Right. Slightly, there is a difference between this atmospheric moisture and humidity. Okay. What is the difference? I'll tell you. Say, for example, if I just talk about, say, for example, having taken all this atmospheric, say, for example, water vapor present in entire atmosphere, you call them as what? Atmospheric moisture. But when I talk about, say, for example, measuring the water vapor, right? Say, for example, in a particular air mass, I call them as what? Humidity. Okay, both you can take it, my friend, side by side. Okay, so kindly take it. I repeat. I repeat. Water vapor present in atmosphere. Water vapor present in atmosphere is called as atmospheric moisture. Water vapor present in atmosphere is called as atmospheric moisture. Whereas water vapor present in an unit, okay, water vapor present in a specific air mass, water vapor present in a specific air mass is called as humidity. It's called as humidity. Okay. Right, my friend. So what exactly is the difference? See, entire atmosphere, say for example, this is entire atmosphere, right? Water vapor present in an entire atmosphere, you call them as what? Atmospheric moisture. But one specific air mass, if I'm just taking it, right, if I just talk about this measuring the same, I call them as what? Humidity. That's it. Am I right? Right, my dear friends. Okay. So what is atmospheric humidity or atmospheric moisture? Approximately, we have an idea. Now comes the question, okay, everything is fine. What exactly is the source, right? How exactly this atmospheric moisture is added to the atmosphere? That's the question, right? Let me call it as a source, my friend. Of course, source is water, no denial about it. But what are the different ways how exactly this water vapor is added to the atmosphere, if you ask me? Of course, right? We were talking about evaporation, no denial about it, right? No denial about it. This is evaporation, right? Evaporation. Right. Apart from evaporation, my friend, what are the other, say, for example, right? Other ways, other process by which this water vapor is added, if you ask me, right? Evaporation, like evaporation, what you have is what? Transpiration. Okay. Say, for example, from the leaf of the plants, transpiration. Transpiration. Okay, that's the reason. Always we say, normally we say, right? It means water body is very important to facilitate precipitation. To have precipitation. Forest is very important. Why forest? Only when an air mass is passing through a forest you have a lot of trees. Never right. So through transpiration, whenever the photosynthesis is taking place, through the leaves, this water will be lost, right? That's what you call them as what? Transpiration. Okay, right. So transpiration also adds water vapor to the atmosphere, right, my friends? So evaporation and transpiration, they have a rate. Then, my dear friends, even say for example, if flora can add, fauna can also add. Even we can add, my friend, when respiration. Okay. Even during respiration, this water vapor is added, but see, very minimum. But only thing is that I'm just telling you approximate sources. Respiration. Okay. So evaporation, transpiration, and respiration, my friend. Okay. So say for example, at others, say for example, some other places, right? I would say, if you are there in a polar region, ice caps. Am I right? Now what happens? Even without this ice cap becoming water, directly from ice caps, water vapor is added to atmosphere. That process we call them as what? Sublimation. Solid to gas, direct solid to gas conversion. We call them as what? Sublimation. Okay. So these are some of the ways how exactly this water vapor is added to atmosphere. But if it's even volcanic activity, if you want to add it, you can add it. Volcanic activity. Right? You can talk about volcanic activity. See, why volcanic activity? I'll tell you. See, for example, how did the oceans of the world came into existence? Somewhere you call them as what? Degassing. Degassing is a, right, say for example, common, right, activity which happens along this volcanic activity. Whenever this magma is coming to the surface of the earth from Earth's interior, it also carries substantial amount of gases. And the predominant gas, what gets emitted during any volcanic activity, apart from sulfur dioxide and carbon dioxide, the most predominant gas is what? Water vapor. 70% of the gas released during volcanic activity is what? Water vapor. That's the reason. After any volcanic activity, precipitation is very normal or precipitation is very common, my friend. Right? Very, very common or very, very normal. Am I right? And my dear friends, I have just given you 5 different sources, right? I should not say source, process by which water vapor is added. Okay. I'm telling you, this is not limited, right? It goes. But these are the major, right? Say, for example, major activities through which water vapor is added. Okay. Now, what is humidity? We understood. How this atmospheric humidity is added to atmosphere, that also we understood. Now comes the question. How do you measure it? We're talking about measuring this atmospheric humidity, right? Let me call it as what? Measure of humidity, my friend. Measure of humidity. Okay. Generally, there are 3 different ways of measuring humidity. 3 different ways. Okay. See, only one is very effective. All the rest of the 2, we don't even use it. But still, let me tell you that there is a, right, such a way, right? What are they, my dear friends? Number 1, you call them as what? Absolute humidity. You call them as what? Absolute humidity. Now, what is this absolute humidity, if you ask me, my friend? Okay, say for example, what is humidity? Amount of water vapor present in some specific air column. Correct? In that regard, my friend, the amount of water vapor, right, measured in grams, am I right? Measured in grams, present in 1 meter cube of an air column, my friend, right? 1 meter cube of an air column. Okay, you call them as what? Absolute humidity. Okay, so I would say this amount of water vapor, okay, measured in grams, right, present in, right, 1 meter cube of an air mass or air column, you can take, right? 1 meter cube of air column, right? 1 meter cube of an air column. Am I right? This is what you call them as what? Absolute humidity. I hope you can understand, right? Say for example, Approximately, you are just taking, say, for example, 1 meter cube. Okay. Somewhere you are just, say, for example, selecting 1 meter cube of an air column. I hope you can understand what is this 1 meter cube, correct? All sides, right? The length, breadth, width, everything will be, right, 1 meter. Okay. All sides it will be 1 meter. Okay, 1 meter. Right, 1 meter. Right. So if you are just, say, for example, calculating what amount of water vapor, say, for example, is present, right, within this air column, this is what you call them as what? Absolute humidity. Okay. Now, if you want to write it as you can write it. Otherwise, very simple. Amount of water vapor measured in grams. Symbolically, I have told you, measured in grams, present in 1 meter cube of an air column, right? Of an air column, you call them as what? Absolute humidity. But what is the problem of this absolute humidity? I'll tell you, it keeps on fluctuating. Because what happens? See, for example, if temperature increases, am I right? Say, for example, it will expand. If temperature increases, it will expand. Okay, if temperature increases, it will expand. If temperature decreases, it will contract. Am I right? It will contract. Okay. So what happens? It keeps on fluctuating. Right? That's the reason absolute humidity is not the best way to measure humidity. It is not the best way to measure humidity. Okay, right. Even if you want to note it down somewhere, you can note it down. Absolute humidity, it keeps fluctuating. Am I right? Fluctuating with fluctuating temperature. Okay, kindly write it. It keeps fluctuating with fluctuating temperature. Okay. Number 2, my friend, right? Absolute humidity has no climatological value or climatological code. Forget about it. Then the second way of measuring the specific means almost humidity comes in the name of what? Specific humidity. Specific humidity. Okay. So when I talk about specific humidity, only small difference. Okay. Absolute humidity and specific humidity, if you ask me what exactly is the small difference, same. Amount of water vapor measured in grams present per 1 kg of an air column. Am I right? Right, 1 kg of an air column, or you call them as what? 1 kg of an air mass. Okay, that's the only difference. Amount of water vapor measured in grams per 1 kilogram of an air mass. Okay, see, when I talk about air mass, name itself says mass, air mass. Okay, 1 kg of air column. Okay, now what is the difference? Number 1, earlier it is amount of water vapor present in 1 unit volume of air column. The second, amount of water vapor present per unit mass of an air column. See, for example, specific humidity will not fluctuate. Why it is not fluctuating? Because I understand if the temperature increases, yes, it will expand, but with the expanded air mass, the weight of mass is going to remain the same. So it is not going to fluctuate. Am I right? With this help of the specific humidity, at least you can identify whether the given air mass is a dry air mass or wet air mass. In that regard, right, entire world, if you ask me, what exactly is the driest air mass? Right? Driest air mass. The driest air mass is identified, right? Having somewhere around, right, 0.2 grams of water vapor present in 1 kilogram of air column. This is the driest air mass. If you ask me where exactly this driest air mass is identified, right? Polar regions, right? Polar regions. Right? So polar regions happens to be the driest air mass in the entire world. Right? On the other hand, if you ask me wettest air mass, right? Wettest air mass. See, this facts changes from books to books, right? But all the facts taken together, it is somewhere around 40 grams of water vapor present in 1 kilogram of air. Where, right, generally, my friend, equatorial rainforest is considered to be the wettest region in the entire world, rainforest. Okay. So at least it will tell you where exactly you have the driest air mass and where exactly you have the wettest air mass. Okay, specific humidity. But what is the problem of specific humidity? Specific humidity will not tell you whether it will be precipitating. Whether it will go for condensation or not, this will not tell you. Okay. The best way, right, which say for example, how you can predict the weather, right? If you ask me in that regard, right, it is by the measure of, right, the relative humidity, my friend. The third way is the most effective or climatological way of measuring, right, humidity. Okay, you call them as what? Relative humidity. Okay, you call them as what? Relative humidity, my friend. Okay. Now, what is this relative humidity? Say, for example, RH, right? Very, say, for example, even if you're almost, say, for example, whenever you are looking for a weather information, always you will be finding this relative humidity. Relative humidity is 90%, relative humidity is 80%, relative humidity is 100%, 98, 99. This is what it is. All right. So, what is this relative humidity? At least this will give you a chance to differentiate between saturated and unsaturated masses. What is the importance is knowing whether it is saturated or unsaturated air mass. My dear friends, see, for example, very recently, when I talk about, say, for example, Middle East countries, right, Middle East countries, they were experiencing very, very hot climatic conditions, very hot. Even when I talk about Canada, when I talk about, say, for example, the European countries, particularly France and other countries, they were experiencing so much of heat waves, am I right? Now, say, for example, in this heat wave condition, right, they thought that, okay, the best way, say, for even Russia, right, they were experiencing this heat wave condition, right? They thought that the best way to reduce this heat wave condition is to, say, for example, sprinkle water on the, say, for example, the patrons who are roaming in the streets. Then Middle East thought, okay, why don't we go for cloud seeding? Okay. They're just going for cloud seeding, you can reduce means, it means, say, for example, it may result in what? Artificial rain. Am I right? Now comes the question, will this cloud seeding work in all types of, say, for example, air mass? If you ask me, no. Only the saturated air mass, this cloud seeding will work. Right. If I want to result, say, for example, if you want to produce artificial rainfall, air mass should be saturated. Only then you can go for cloud seeding or inducing artificial rain. Then how do you identify whether this is saturated or unsaturated air mass? It is by knowing this relative humidity, my friend. Very important. Okay. Right, my friend. So in that regard, okay. Right. So when I talk about relative humidity, what is this relative humidity? My dear friend, it's very simple. Relative humidity is a ratio. Ratio between what? Ratio between, right, the amount of water vapor present in an air column. Right? Right? Amount of water vapor present in an air column, okay, in any air mass to its carrying capacity. Carrying capacity, okay, at a given temperature, at some given temperature. Carrying capacity at some given temperature. Why I say carrying capacity at some given temperature means carrying capacity will change with the changing temperature. Okay. So amount of water vapor present to its carrying capacity at a given temperature. And this is a ratio, and always it is expressed in percentage, my friend. Okay, into 100. Okay. See, for example, amount of water, see, every air mass has a carrying capacity. See, for example, something like this bottle, my friend. This bottle has a carrying capacity. Am I right? Only till this I have water. Am I right? So somewhere I understand. Assume that this is air mass. Only till here I have water vapor, right? Say for example, this can be somewhere around 30 or 40. Am I right? So if I'm just going to add water to it or water vapor to it, at one point of time it is going to become full. Whenever this bottle is full, something like an air mass, you call them as what? Saturated air mass, my dear friend, right? Generally, right, if air mass, if relative humidity is 100%, if it is 100%, right, then the same you call them as what? Saturated air mass. Right, you call them as what? Saturated air mass. Relative humidity is 100%, you call them as what? Saturated air mass. If relative humidity, say for example, is less than 100%, right? If relative humidity is less than 100%, then you call them as what? Unsaturated air mass, right? If it is equal to 100%, then you call them as what? Saturated air mass, right? If it is less than 100%, you call them as what? Unsaturated air mass. It is called as unsaturated air mass. Okay. Now, why it is so important to know about this saturated and unsaturated air mass, right? Only the saturated air mass may result in condensation. Okay, right? May result in condensation. Condensation is a prerequisite for precipitation. Without condensation, you cannot have precipitation. Without the cloud, there is no rainfall, as simple as this. Right. So that's the reason, my friends. See, for example, only if this relative humidity becomes 100%, right, or saturated air mass, it may go for condensation. I repeat again, if you want to take the definition, you may kindly take it, my friend. The amount of water vapor, present in an air column, the amount of water vapor present in an air column to its carrying capacity, at some given temperature, is called as relative humidity. It's called as relative humidity. And relative, the last sentence you can write. It is, okay, relative humidity is expressed in percentage. Relative humidity is expressed in percentage. Okay. So what is relative humidity? Approximately, we have an idea. Okay. As I said, what is relative humidity? We have an idea, right? Now, normally I told you, right, say for example, only saturated air mass will result in what? Condensation. Okay. Now comes the question, how do you make, how do we make means I'm not talking about how exactly we are making it. Say for example, how exactly nature facilitates. How one unsaturated air mass can become a saturated air mass, if you ask me. Of course, I understand the relative humidity value should increase. Now comes the question, how this RH, relative humidity, will increase? Two ways, my friend. Either you can increase the amount of water vapor present. Say for example, this bottle I said, right? You can fill water, and water, make it full, or you can also reduce the carrying capacity. How do you do it? You reduce the size of the water. Water is same. Water inside the bottle is same, but we start crushing it. Am I right? So that at one point of time, the volume of the bottle and the water inside becomes equal. Am I right? So, my dear friend, there are two ways how exactly this relative humidity can be made as 100%. There are two ways how unsaturated air mass can become saturated air mass. Number one, you can increase the amount of water vapor present, add it, but you have a restriction. Say, for example, if this air mass, say, for example, passes, or this wind, right, pass over a water body, it crosses a forest, right, water vapor will be added. Evaporation, transpiration, all this will add water vapor. That is okay. But what about the interiors where you don't have this source? There is no forest, right? There is no water body, but still it may result in condensation. How? Right, my dear friend? The second way, the most popular way, is reduce the carrying capacity. How? How you can reduce the carrying capacity? Simple, reduce the temperature. If you reduce the temperature, this air mass or this air column is going to get contracted, right? Something like crushing the bottle. Am I right? So slowly, slowly, when the carrying capacity decreases, automatically percentage increases. Am I right? I'll give you an example, practical example. And one more thing, my dear friends, if you ask me how exactly you can reduce temperature, simple. In atmosphere, if you want to reduce the temperature, very simple, increase the height, or what I call them as what, altitude. Increase the height. That's the reason I said, oh, mountains are very important. If I have a mountain, right, this wind can rise along the slopes of the mountain. With every attempt of this wind rising along the slope of the mountain, it becomes cold. By becoming cold, the carrying capacity decreases. That's it. All right. Right, my dear friends. In that regard, I'll just give you one example. Right, one example. Right, say for example, some air mass. Right, some air mass. Okay. Say for example, this. Right. And say for example, right, the temperature. Given temperature is around. Right. Say for example, at some given temperature. Right. Right. Water vapor present. Right. Carrying capacity, I'm writing it as CC, my friend. Right. You write it as carrying capacity. Okay. Then we'll calculate what exactly is the relative humidity. Right. Then we'll know the what exactly is the nature of this air mass. Okay. Now, my dear friends, okay. Some very crude example I'm just going to give you. Okay. Very crude example. Okay. What is a crude example? I'm just taking some air mass, right? Say for example, at given temperature is what? 20 degrees centigrade. Okay, 20 degrees centigrade. The water vapor present in this air mass is 5 units, my friend. 5 units. Okay. Carrying capacity is somewhere around 10 units. Okay. Water vapor present is 5 units. Some random crude example, you may not find this example in reality. Forget about it. Okay. Water vapor is 5 units. Carrying capacity is 10 units, my friend. If that is the case, you can calculate this relative humidity. The relative humidity will be 50%. Am I right? So 50%, anything which is less than 100, you call them as what? Say for example, unsaturated air mass. So this air mass becomes unsaturated air mass. Right? This air mass is unsaturated. Now you know how exactly one unsaturated air mass is made as saturated air mass by, right? Say for example, making this relative humidity as 100%. How do you do so? I told you two methods, right? Supply, increase the supply of water vapor or decrease the carrying capacity. What nature does decrease the carrying capacity? How? Very simple. Reduce the, say for example, right, temperature, my friend. Slightly I'll change the value so that calculation becomes easy. Let it be 10 units and let it be 20 units. Okay. So that the calculation becomes easy. So I'm not decreasing the amount. Water vapor is same, right? 10 units. There is no difference. Okay, 10 units. Okay. But now the carrying capacity with decreased temperature, carrying capacity comes down. It becomes 10 units, my friend. Right? If the carrying capacity becomes 10 units, water vapor present is also 10 units, then the air mass becomes 100%. This is what I call them as what? Saturated air mass. Now you may wonder, right? What will happen If you further reduce the temperature, theoretically, assume that I'm just making it right 8 degrees centigrade. Water vapor is not going to change, right? It's going to be 10 units. Am I right? But the carrying capacity gets reduced to 8 units, my friend. In that regard, say for example, I'm just giving you a crude example which may not exist in reality. Relative humidity become 125%. Right? Some of you would have thought 120, right? You calculated it will be 128. Am I right? 8, right? 10 divided by 8, right? It should be 125. Okay. My dear friends, this occasion where air mass becoming more wet, am I right? You call this as supersaturated air mass. You call them as what? Supersaturated air mass. Okay. So let me tell you, my friend, not only saturated air mass, you also have supersaturated air mass. Am I right? Only these two air mass may result in condensation. May result in condensation. Okay. See, when I talk about the supersaturated air mass is an extreme condition. Right. For condensation to take place, you need something called as hygroscopic nuclei. This hygroscopic nuclei is generally missing. Right. It becomes elusive. Right. That's the reason when saturated air mass becomes supersaturated air mass. Okay. Right. So what is this atmospheric humidity? Right. In general, we have an idea, my friend. Okay. How exactly this humidity is calculated? Right. What is atmospheric humidity? How this humidity is calculated? Everything we have an idea. Okay. Right. So this is all about atmospheric humidity, my friend. Okay. Now, after understanding this atmospheric humidity and water vapor in atmosphere, let us go to the second component. What do you call them as what? Condensation. Okay. See, what is this condensation, my friend? Water vapor is gas. Gas either becoming solid or liquid, you call them as what? Condensation. As simple as this. Okay. So that also you'll write it. So second topic, what we are going to discuss about is what? Condensation. The second compartment of the cycle, right? What we are going to discuss is about this condensation, right? Okay. What is this condensation? See, the process of gas, right, either becoming solid or liquid. Solid or liquid, you call them as what? Condensation. In that regard, the gas what we have is what? Water vapor, right? So, water vapor, correct? Water vapor either becoming solids or liquid, I would say, water droplets, or ice crystals, right? Say for example, gas becoming solid or liquid, okay, solid or liquid, you call them as what? Condensation. So in that regard, my friend, water vapor becoming, right, liquids like water droplets or solids like ice crystal, this is what you call them as what? Condensation. The same thing, if you want to write it also, you can write it, right? The process of water vapor, either becoming water droplets, or ice crystals, either becoming water droplets or ice crystals, is called as condensation. It's called as condensation. So what is condensation? You know, Mike. Now if I say, okay, when exactly condensation will take place? Already I told you, right? Prerequisite conditions for condensation. Of course, I understand. Number one, you should have saturated air mass and supersaturated air mass. Let me say at least saturated air mass. At least saturated air mass. At least saturated air mass. Okay. Whenever I say at least saturated air mass, what is the meaning of this word at least saturated air mass, if you ask me? Right? What is the meaning if you ask me? At least saturated air mass. It means this is the air mass where the relative humidity, am I right? Say for example, is equal to or more than 100%. Am I right? It means this at least saturated air mass includes both what? Saturated and supersaturated air mass. That is the meaning. Right. So this saturated or supersaturated air mass along with this hygroscopic nuclei, my friend. Hygroscopic nuclei. You call them as what? Hygroscopic nuclei. What is this hygroscopic nuclei? Water seeking solids. Right? Somewhere you can write. Hygroscopic nuclei is nothing but what? Water seeking solids. My dear friend, only this saturated or supersaturated air mass along with this hygroscopic nuclei will result in condensation. This understanding is very, very important, my friend. Even I have just given you a clue, if you remember. I said harmattan as a wind. Why exactly this harmattan as a wind, right? Say for example, is going for this condensation, if you ask me. Why it is resulting in condensation? So much of aerosol supply is there. So much of hygroscopic nuclei is there. See, all of a sudden water vapor is there. It is becoming saturated. But now comes the question. Where exactly it will go for condensation? You need something, right? Around which this condensation process will get initiated. Hygroscopic nuclei, water-seeking solids should be there, my friend. All right. So if you ask me, okay, give me an example of this hygroscopic nuclei, it can be anything, my friend. It can be an aerosol, right? Some solids, right? To be very precise, they are water-seeking solids. Water-seeking solids. So the surface tension, what it is associated with it, it will allow me, almost it will make the water to get, say for example, initiate the condensation process along with it. And once it increases, right, I understand, right, slowly, steadily again, once it becomes liquid or solid, this can, say for example, multiply it. It can multiply as such. Okay. Now, as I was saying, my friend, right, only this saturated air mass along with this hygroscopic nuclei may result in condensation. Okay, right. So everything is fine. If you ask me, okay, give me an example of hygroscopic nuclei. The finest example of hygroscopic nuclei is aerosols. That's the reason I said, right, dust winds, fine particles of sand, aerosols. Okay, fine particles of sand, you call them as what? Aerosols. Right. Now, my dear friends, if aerosols are not there, that is the situation where the saturated air mass further becomes supersaturated air mass. See, cloud seeding, artificial rain. I mean, what exactly they do, right? Silver iodide or somewhere electrified sand they will be throwing. This electrified sand is nothing but what? These aerosols. Correct. Readily it goes for condensation. Normally it happens, Michael. Normally it happens. Say, for example, even you can experiment it. Say, for example, even in your room, right? Even in your room, you increase the water vapor, right? Increase the water vapor, right? Water vapor content is there. Slightly, if you say, for example, through electrified sand, you will understand that precipitation you yourself can result, means almost cause this precipitation. Okay, right. On what occasion condensation is resulted, we have an idea. Now, what we'll do, my friend? Now we'll talk about the different forms of condensation. Okay. Different forms of condensation. Okay. Assuming that what exactly is condensation. Now we'll talk about different forms of condensation. Okay. Right, maybe my friend, at least we can go for three different, understanding these three different forms of condensation. What are they? Say for example, condensation that is taking place on the ground. Okay. You call them as what? On ground condensation. On ground condensation. Condensation which takes place high in the atmosphere, you call them as, okay, orange straight. Condensation which takes place near the ground, you call them as what? Near ground condensation. Okay. Condensation that takes place high in atmosphere, we call them as what? Atmospheric condensation. Okay. We call them as what? Atmospheric condensation. Okay. Right. On ground condensation, near ground condensation, and atmospheric condensation. My dear friends, these are the different forms of condensation what we have. Okay, these are the different forms of condensation, as I was saying: on ground, near ground, and atmospheric condensation. Name itself says, right? The condensation takes place on the ground, the surface of the earth itself, on ground condensation. If you ask me, okay, everything is fine, right? What exactly this on ground condensation is very popularly called as, my dear friend? This on ground condensation is very popularly called either as, right, say for example, dew, or it is called as frost, right? It is called as dew, right, or it is called as frost. Okay, dew or frost. Then what about near ground condensation? Near ground condensation is very popularly called as fog, or sometimes it is called as mist. Okay, it is called as fog, or sometimes it is called as mist. Then what about the atmospheric condensation, my friend? This atmospheric condensation is the most commonest form of condensation. You ask me, okay, what exactly is this atmospheric condensation? What it is called as? It is called as cloud. It's called as cloud. Okay, right. And my dear friends, take it from me, this forms of condensation is very, very important. Very, very important. Okay, so on ground, near ground, and atmospheric condensation. Okay, one by one we'll see. When talk about on ground condensation, what is what we see? See, for example, on ground condensation. See, geography is one subject where you can very easily relate things, am I right? You can see, for example, every day you see these things. I mean, say, for example, you are there in, right, say, for example, winters, right? It is very common. On ground condensation is common during winters. Common during winters. Okay, it's very common during winters. On the ground itself. Let's say, for example, assume that you are going for a morning walk. While you are going for a morning walk, my friend, normally you will be finding that, say, for example, in the grasslands, you'll be finding small, small water droplets. Extreme winters, right? Say, for example, if you're there in mountainous regions, winters, you'll be finding small, small ice crystals that is attached to the plants. All right, that's what you call them as what? Right, frost. Okay, I'll show you that how exactly this dew and frost looks like. See, small, small water droplets, what you find it in the grasslands, right? This is what you call them as what? Dew. Okay. Ice crystals, what you find, right? Covering the plants, right? See, for example, here, what exactly you're seeing here, ice crystals, right? So ice crystals, what you're seeing is what? Frost, my friend. What exactly you're seeing here is dew drops, right? What you're seeing here is what? Frost. Okay. Maybe for your reference, I'll just copy this image here. See, all these things they have explained it. Okay, nothing wrong in having this. Okay, but don't take it that much seriously. Okay, now here, for example, I'll just tell you how to remember this very easily. Right? When talk about, see, I said it is common during winters, my friend. Normally, what happens during winters, this air mass will start descending down towards the surface. Surface will be extremely cold. By the time this air mass comes into contact with this surface, it results in a phenomena called as surface cooling. Right? Or you call them as what? Contact cooling. Right? Okay. It results in the process called as contact cooling. Contact cooling. See how I can understand this contact cooling. I do not know how many of you are using ACs. You're using AC. Am I right? This pipe of this AC, you'll be finding that ice is formed over this pipe. Okay, forget about it. You take one extremely cold bottle of water from the fridge and keep it on your table. After some time, you'll be finding this bottle. Say, for example, the outside of the bottle, you'll be having many water droplets. Now comes the question, from where exactly this water droplet has come? From where? From atmosphere. Now what happens when this, say for example, air mass comes into contact with the extremely cold surface of this bottle? Right? This bottle surface is so cold that bottle surface itself acts as this hygroscopic nuclei. Right? It goes for ready condensation. That's what we call them as what? Contact cooling. Coming into contact with the surface of the earth. During winters, the surface of the earth will be extremely cooled. Am I right? So with all means, am I right? It results in what? Condensation. Am I right? Coming into contact with extremely cold ground condition. Okay, everything I understand. My dear friend, what is the difference between dew and frost, if you ask me? Dew is a water droplets, my friend. Water droplets. Water, as simple as this. When I talk about frost, okay, frost is nothing but what? Ice crystals. Frost is ice crystals. Okay. Now comes the question, when exactly the water droplets will be formed? If surface temperature, simple, right? Don't take it so seriously. Surface temperature. See, for example, it is coming into contact with the ground. Same water bottle I told you, right? You take the water bottle from the refrigerator and keep it outside, the water droplet will be formed. If you take the bottle of ice, or if you take the bottle of ice which is frozen, take it from the freezer and keep it outside, ice crystals will be formed. So what exactly happens if the surface temperature has, right, say for example, more than 0 degrees centigrade, am I right? 0 degrees centigrade, then water droplets will be formed. On the other hand, if the surface temperature is less than or equal to 0 degrees centigrade, then ice crystals will be formed. As simple as this, right? Extreme cold condition, frost. Moderate condition, dew. But both will happen only during what? Winters. Okay, right. So what is dew? What is frost? We have an idea. Normally, my friend, dew is good for plants. Frost is not good for plant. Frost will affect their respiration. Frost will affect their photosynthesis process. Am I right? So frost is not good for plants. Okay. Right, my dear friends. So on-ground condensation we have seen. After talking about on-ground condensation, the next topic what we have to discuss is what? Near-ground condensation. Okay, near-ground condensation. Near-ground condensation. See, when I talk about near-ground condensation, it means what? Say, for example, it happens near the ground. Okay. Right. What is near-ground condensation? Right. I would say near-ground condensation, you say whether it can be fog or it can be mist. Okay. It can be fog or it can be mist. What is a fog, if you ask me, right? What is a fog? Let me tell you. Simplest way. See, actually, technically, there is a hell of a lot of difference between fog and mist, but I'm trying to make life slightly simple. If you ask me what exactly is fog, I would say fog is nothing but what? Near ground cloud. Cloud that which has descended, right, to the surface of the earth, right? Cloud which has come to visit us. You call them as what? Fog. Then what exactly is mist, if you ask me? Though there is technically lot of difference, I am bringing only the basic essence of it. Less dense fog is called as mist. Less dense fog is called as mist. Simple way of understanding. It means what? Mist visibility will be more, fog visibility will be less. Generally, the visibility will be less than 1 kilometer. Where fog? If you want to write it, you write. Visibility. I was just talking about this visibility, right? This visibility. Visibility will be less than 1 kilometer for fog. When talking about mist, my friend, visibility will be somewhere around between 1 to 2 kilometers. Okay, right. Fog and mist, what exactly is the difference? This is what the difference is. Okay, so near ground cloud, you call them as fog. Less dense fog, you call them as what? Mist. Okay, right, my friends. So this is one. Right. Right. So what is fog? What is mist? We have an idea. Now, my dear friends, when I talk about the types of fog, right? Types of fog, right? Generally, there are, say, for example, see, most of you would have seen this fog, and I'm telling you again, when I talk about, say, for example, fog in lower latitude, it is common during winters. Am I right? You call them as what? Radiational fog. Number one, you call them as what? Radiational fog. Radiational fog. What is this radiational fog? All this fog, what exactly we are seeing or we are experiencing in lower latitude is nothing but what? Radiational fog, right? They are, say, for example, common during winters of lower latitude, my friend. Winters of lower latitude. Right. Generally, they're common during winters in lower latitude. You call them as what? Radiational fog. Right. Apart from radiational fog, you have something called as frontal fog, my friend. Frontal fog. Now, what is this frontal fog, if you ask me? Right? Frontal fog. Front as a mechanism, right? Already once in class we discussed about front. Am I right? So this front as a mechanism, right? Where exactly it will be means, right? You'll be experiencing this if you ask me, right? You will experience this along the right mid latitudes, my friend. Mid latitudes. Right? Mid latitude. Somewhere around the 60-degree, right? Somewhere around the 60-degree latitudes throughout the year, you will be experiencing this front, right? Along front, you will be experiencing this frontal fog throughout the year. Okay. Then we have something called as advectional fog. Advectional fog. Okay. Advection means wind, my friend. Okay. So what exactly you experience, right? In Western European countries, particularly to be very precise, right? This advectional fog is common in Western Europe, particularly United Kingdom, my friend, UK. What you experience is what? Advectional. See, you also have a fog called as precipitational fog, but that is not important. Okay, radiational fog, lower latitudinal winters, frontal fog somewhere around 60-degree, right? Both northern and southern hemisphere, right? Throughout the year, and advectional fog in Western Europe. Am I right? This much should be fine enough. Okay, right. So, my dear friends, when I talk about this hydrological cycle, right, I talked about condensation. Sorry, I talked about this atmospheric humidity. After talking about atmospheric humidity, the second compartment of cycle, right, condensation, I talked about. Okay. In condensation, at least three types of condensation or three forms of condensation we have taken it. On ground condensation, near ground condensation, and atmospheric condensation, right? Dew and frost we have completed, fog and mist we have completed, cloud it is left behind. Am I right? So somewhere I would like to conclude the class here at this moment, my friend. The rest of it we'll see it in the next class. Okay. So when is the next class? Chris sir will update you. Okay. Right. So somewhere let me say, for example, conclude the class here at this moment. Okay. If you have any doubts, we can interact. . Okay, no doubts. Thank you. Right. Right, my friends. So next class, the sir will be telling you. That should be fine enough. Two more classes, we can complete this complete climatology. Okay. Right. Climatology is very important for your examination also, my friends. Okay. So thank you and God bless.